Hi friends, welcome to the Unit 2B Day 7. This really talks about the converse of the corresponding angles postulate. The corresponding angles postulate, go ahead and review that from a previous section if you don't remember what that is. But really what we're going to do is we're going to be talking about when we have a transversal cutting through two parallel lines and what that does to those actual angles that are kind of the result from that. So here we have if two coplanar lines are cut by a transversal. So basically it means that the lines that are there if there's another line that intersects them. So if you have two lines and then you have another line that intersects them, and then what that does is that if that intersecting line, if that produces two corresponding angles, then I know that the lines are parallel. And they have to be because this angle being corresponding to this angle, remember, corresponding angles are congruent. So if these two angles are corresponding, then I know that these two lines are parallel. So the conclusion, so the hypothesis here says if this, remember hypothesis, if this, so if we have a transversal that cuts through the two lines, and then it makes corresponding angles. I shouldn't say two. It actually makes four sets of corresponding angles. These are just the ones that we labeled. So there's corresponding angles on all the rest of this as well. Then the conclusion is, then M is parallel, so line M is parallel to line N. So that's what that means. And we call this a postulate because we can then use this to prove a bunch of theorems. We don't prove the theorems in this course. That would be for another, a different math course. But just to know that the names, like this is called the postulate, the converse of the corresponding angles postulate. This should actually be the word postulate, not theorem. Postulate instead. But then we're going to use this to talk about these theorems. So now that we have these different theorems here, all of these theorems are based off this postulate. So it's all just different ways of thinking about it. So here we have the converse of the alternate interior angles theorem. So this is the converse of the alternate interior angles. So that means we're going to be talking about alternate interior angles. If two coplanar lines are cut by a transversal so that a pair of alternate interior angles are, so these angle 1 here and angle 2, so if these are congruent, then we know, again, the lines are parallel. The lines are parallel. So again, same conclusion. Then M is parallel to N. Same idea here as we talked about with the corresponding angles from up above. Because we have alternate interior angles and they're congruent, then I know that the lines are parallel. This goes very similar to what we were talking about earlier when we were talking about the alternate interior angles theorem, the corresponding angles theorem. Now we're doing the converse of the alternate exterior angles. So now you see that there's a kind of a theme here with all of these. We're going to be talking through the different theorems, but we're talking them in a different way. So here we have two coplanar lines are cut by a transversal so that a pair of alternate exterior angles are congruent. Again, same idea. Then the lines are parallel. Oops. Helps if I spell parallel correctly. Are parallel. So again, same idea. So angle 3 and angle 4 are congruent. Then line M is parallel to line N. And then the last one, converse of the same side interior angles theorem. So this is the one that's slightly different because when we have the same sides, that we know that this is kind of different because these can't be congruent. You can actually visually remember that these normally you have one obtuse and one acute, unless they're both 90-degree angles. But then in this case, what you need to remember is that these here form a line. They make a line. They make 180 degrees. So these are going to be supplementary. So if two coplanar lines are cut by a transversal so that a pair of same side interior angles, again, this one, the same side interior angles theorem, then the lines are parallel. Then the lines are parallel. then, so if this is true, then M is parallel to N. Join me in the next video as we talk about some examples with this. Have a wonderful day.